Sometimes the only way to build the right thing is to build the wrong thing again and again and again until you get it right. Today I'm going to be talking about how crypto and how BOS have been perfect examples of building the wrong thing so that we can eventually get it right. So let's talk about that. One of my favorite quotes is an Edison quote where he says, he's quoted as saying that after he tried hundreds of different filaments for creating light bulbs, and all of them failed. Eventually he found one. But before he found one which actually led to the creation of the light bulb, he was talking about his failure, and somebody asked him about his constant failure, and he said, well, I haven't failed, I've just successfully found another way in which this doesn't work. Why is that relevant to crypto and blockchain and what is happening in our world right now? Well, we've been on a long journey of figuring out what the right thing is by doing the wrong thing again and again and again. Most people think that the beginning of the crypto industry, of the digital asset space, of self-sovereign digital assets, the beginning of the story was Bitcoin. But that wasn't the beginning of the story. That was actually the end of part one. Part one was throughout the 90s and the first decade of this century. People had been trying all kinds of ways. If you look at the Satoshi white paper and you look at the citations, there's Hashcash, there's eGold, there's a bunch of different attempts are cited by Satoshi as providing him with inspiration for creating Bitcoin. And so it is through the process. Innovation is really the process of failure, the process of trial and particularly error on the way to success. Eventually we ended up with Bitcoin, which created this asset which is now very, very clearly winning in a big way. A multi-trillion-dollar asset, faster growing than Tesla, more valuable and faster growing than Nvidia over the course of the last 15 years. And now being adopted on a nation-state level by all kinds of countries around the world, not least of which is the most powerful economy in the world, the United States. But to get there, we failed a lot. With smart contracts, the idea was, let's take this idea. Let's take the success that was demonstrated in Bitcoin and expand it. Let's not just have one asset which can be self-sovereign, which people can directly own. Let's make direct ownership something that you can do over a large number of assets. And let's make direct ownership something that you can do with the services and the applications and the financial services, like the DeFi services that you use with these financial assets, be it lending or trading or options or capital markets creation. Let's put all of that, the idea was, on-chain. And the reason that the thinking was, let's put it all on-chain, was because the example was Bitcoin. And Bitcoin had put everything on-chain. And so people for a long time, even to today, thought that the way that we need to build sort of the next generation that comes after Bitcoin, right, that comes after just digital gold, but the way we create a world of digital self-owned assets is by putting it all on chain. And we've tried a lot of different ways to do this, and none of them have accomplished the goal. None of them have created a truly self-sufficient economy outside of traditional finance. None of them have created systems where people are managing their finances outside of gambling and speculation. So Ethereum has failed to do that. BNB failed to do that. Avalanche failed to do that. Solana failed to do that. And All of these other things, XRP that came before, have all failed to do that. And today I'm going to talk about why they failed to do that. But I want to tell my personal story, because in 2011, when I first discovered Bitcoin, it wasn't so much digital gold that captured my imagination. It was the idea of having property rights on the internet that captured my imagination. And I thought that Bitcoin was just going to be the first example of many assets that we would be able to digitize and give people true ownership of, and therefore that we would be able to create a economic system which didn't care who you were or where you lived, didn't care about borders, was accessible to everyone, and gave everyone who had connection to the internet connection and the ability to access property rights, and therefore would be able to create prosperity and freedom that we'd never seen before on a scalable, in a way that is more scalable than anything we have created through sort of soft liberal arts laws and social contracts. And the way that I thought that this would become popular was that I believed that gaming was where it was going to happen. Because gaming is the one environment in which people are already digitally native, the economy is already digitally native, the character's life is already digitally native, the assets are already digitally native. That is where true property rights that were inherently digital seemed to me to be most obviously already in existence. And so I stopped what I was doing, which is working on sort of a biotech machine learning project. And I went to work at a games company. And I had this belief, which was very, very wrong, that we were going to see gaming come online, come onto the blockchain. Back in 2011, that was probably before most people thought that way. And so I was a bit earlier to the mistake, and maybe also a bit earlier to the lesson, that is never going to happen. But I also had this belief that it was probably going to happen with Bitcoin, because the other thing that I believed is that finance, property rights, digitization, all of these things inherently have very, very powerful network effects. If you think about what Bitcoin is, Bitcoin itself is a network. It's a network of nodes. Its topology, its structure, the way people use it is all a network. The more people that join and start using Bitcoin, the more valuable Bitcoin becomes. That's classic Metcalfe's law, right? Metcalfe's law being the value of a network increases the more people who use it. And not only that, as each person joins the network becomes more valuable to every single other person. Not just the network itself becomes more valuable, but the network becomes more valuable to its users. And so one thing which I believed back then, and I believe till this day, is that if you take away technological limitations from Bitcoin, Bitcoin is ultimately going to become the primary network that we use for digital crypto finance, for digital crypto assets, because network effects are just dominant. All right, so there were two mistakes that I made back then. One was thinking that Bitcoin would be able to evolve into that more quickly. And the second was thinking that the way that this was going to happen was bringing things online. Sorry, not online, onto the blockchain. Now, we've seen many, many attempts to do this. We've seen many attempts to bring all kinds of things onto blockchains. Exchanges, right? DEXs are much slower and less proficient than centralized exchanges. Gaming, people are trying to do it with AI right now. Governance in the form of DAOs. And many, many, many other things have all been attempts to put the actual software onto the blockchain. Today I'd like to talk about why that doesn't work, and how we're releasing something now which I think is going to allow us to finally accomplish this goal, and how we're making it open source. So let's talk about how this doesn't work. All right, so let's talk about gaming, because that's where I started, and I think it's a perfect example. All right, so let's say you want to build a massively multiplayer online game. Right, you're going to have potentially millions of concurrent users performing what you can think of as transactions. So walking forward, looking in their inventory, talking to other users, fighting, grinding, all of these are effectively transactions that they're transacting with each other and with the system. That's millions of users performing many, many millions of transactions. That's a huge amount of data, it's a huge amount of throughput, but mostly it's a huge amount of transactions. Right? How many transactions? Many millions and millions per second. Right? The fastest consensus algorithm that we have today, even if you make it very, very centralized and you put it on giant machines and you basically give up on decentralization completely, right? You only have a few nodes. The very, very fastest consensus algorithm we have today can maybe, theoretically, in the lab, not in real-world environments, but in the lab, accomplish several 100,000 TPS, or transactions per second. That is not enough to run a single MMO, not to mention many, many hundreds of different computer games and thousands of different AI agents and many, many tens of thousands of other pieces of software. So we actually can't bring things on-chain without completely giving up the meaning of on-chain. But does that mean that we cannot bring gaming into the world of digital property? Does it mean that we can't bring all of these other applications into the world of digital property? Does it mean we can't build fast, centralized feeling like exchanges where you can do thousands and thousands of high-frequency trading type transactions in a cryptographically verifiable way? And the answer there is no. We now have new technologies which do not require us to bring anything on-chain. So let's talk about for a second, what does bringing things on-chain mean? Well, on-chain means you take the entire piece of software, all of the data, all of the transactions, you put them into a blockchain, and then you have every single full node rerun every single transaction. So the reason you couldn't put an MMO onto a blockchain is because instead of every user performing a transaction, you'd have every user performing a transaction, then every single other user rerunning that transaction in order to verify that it happened. This is obviously stupid. This obviously does not scale. Right? That is verification via redundancy, verification via rerunning things. But what we need is verifiable compute. We need verifiable transactions without doing any of that. And that technology is now becoming available to us. All right? And so let's talk about an example of how you would do that with a computer game, which is one of the most computationally intense multi-party pieces of activity that we have anywhere in existence. Okay, so let's first talk about how you would build this game. Well, what you would probably do is you'd want to build a game in C++, maybe in Rust, because that's what you need. You need to use that language because that is the language that game developers are familiar with. And the reason that that's the language that game developers are familiar with is because it's extremely performant. It's it allows you to write extremely efficient, multi-threaded, high performance software, which is what's necessary for games. But you'd also, you can't just write a computer game today. No, you need lots of tools, and in particular, you need major game engines. So, for example, you would use something like Unreal Engine, right? Without having C++ and Unreal Engine, you're not going to build a AAA game, right? Maybe you can use Unity or something else, but you need, those components. So already we're in an environment which, looks nothing like any blockchain development that we're familiar with. Okay, but let's say you are a game studio. You want to write in C++ and you want to write in Unreal Engine. That's not enough. You also need another thing. You need to be able to run it on your own data center. All of this needs to be able to run on high-performance data centers so that many hundreds of thousands, tens of thousands, millions of concurrent users can use your system. Today we have technology that allows you to write in C++, in Unreal Engine, put the software on your own data center, right, on servers that you run and own, and still turn all of that into verifiable compute. And the way that that happens is that we can take this compute and we can put it into a ZKVM, which is a system which takes standard code and proves it as a zero-knowledge proof. Now, today that would be quite expensive and slow, but that is becoming exponentially cheaper and faster. And so we already are starting to see game developers actually looking to do this, because if you do that, then this whole thing becomes verifiable compute. And then if you put it into a blockchain, let's call it Bitcoin, this entire thing, the database, the Unity and C++ code, the zero-knowledge proofs, and the way they're being written to Bitcoin, all of that becomes a smart contract. It would become a smart contract beyond anything that we're familiar with today. Vastly more powerful, vastly more performant, and doing way more computation than anyone would imagine writing smart contracts for today, but a smart contract still. Okay, so the technological pieces, and this is the interesting thing, the technological pieces to do all of this, obviously C++, Unity, and data centers exist. ZKVMs also exist. And now, as of today, there's also open source software which allows you to take all of this and put it into Bitcoin. And that thing that became available today, that's BitSNARK. So BitSNARK allows us to take arbitrary computation, turn it into a ZK proof, and then take that ZK proof, put that ZK proof into Bitcoin, and verify it, and actually execute transactions in Bitcoin on the basis of that computation. So this journey that I started, in 2011, when I first got interested in trying to do something like this, is finally here. But it meant that we had to make many mistakes along the way. I made mistakes thinking that you would take all of this and shove it into a blockchain. Many other people made similar mistakes. One of the key mistakes that we've made is actually thinking that the only way we can do verifiable compute is to take all of that computation, put it in the blockchain, and rerun it. When what we really need to be thinking about is how do we use cryptography to our advantage, and that's what ZK cryptography does for us now. Okay, but the story still doesn't end there, because we're taking this even further. You can see that there's another box here, which I'm calling rest of crypto, right? Cardano, Sui, Solana, Ethereum, Avalanche. Once we've got all of this running itself into Bitcoin, we have the ability to take the assets that are created in-game, to take the characters that are created in-game, the reputations that are created in-game, and we can publish proofs of these things in Bitcoin. But then we can use that same ZK technology to allow this to propagate to other chains where these things can be traded, can be used to create identities, or to borrow against, or to be moved from one game to another, and to allow composability between these different chains and composability between different games. That is a near-term future that we are working at making a reality at BOS. So then one question that you might ask is, okay, well, sure, but why Bitcoin? And the answer is twofold. The first answer is where I actually sort of gave that answer early on at the very beginning of this little chat. Bitcoin has the network effects. Where are we going to, like, once this technology becomes available, what is the network that people are going to use? It's going to be the network with the largest network effects. It's going to continue to become the network with the largest network effects. And that's Bitcoin. Bitcoin has another secret advantage. Bitcoin doesn't compete as a smart contract chain. It doesn't try to build other things like DeFi and dApps directly into it. And so it doesn't compete with Sui and Solana and Cardano and Avalanche and Ethereum. But they all compete with each other. And so when there is a hub that they can integrate into, it is going to be Bitcoin. Bitcoin is the credibly neutral network, not just for BTC, not just for institutions, not just for governments, but also and probably primarily for other chains. Okay, so that's reason number one. The second reason is because let's go back to why we have crypto in the first place. Crypto is about security. Crypto is about giving you secure ownership, true self-ownership. And one of the problems with, and this is again like one of those mistakes that we've had to make in order to figure out better ways. One of the mistakes that we've made is that with every new blockchain we've created an entirely new set of security assumptions. So that now it is impossible for most users to even know what is securing their assets. Without sort of being really, really deep into crypto, it's just a confusing mess. But there is one thing out there that everyone can agree on, which is Bitcoin. Bitcoin has, it's the reputation, it's got the trust, it's got the track record, but perhaps even most excitingly right now, it's also got government endorsement like no other network. It is the security layer for digital assets. It is the security layer for an internet of value. And so if we want to have a uniform set of security assumptions, then we're going to need to choose some kind. We're going to need some kind of security assumption that we're going to choose. And it seems to me pretty obvious that this is going to default to Bitcoin. All right, so that is not the way that usually you would describe a technology. Usually people talk about technology by talking about sort of the technology, and then they talk about use cases. Well, I've tried to do is talk about use cases, and actually just one specific use case, but it illustrates all other use cases. AI, DeFi, DAOs, anything you can imagine really runs into exactly these problems. It's too transparent, too on-chain, too slow, too expensive. It does not scale. But now let's talk about the technology which is allowing this and that we are open sourcing today. Right? So today we open sourced BitSNARK. And what BitSNARK does is, I think, revolutionary in its simplicity. Let's talk about smart contracts. Most people think about a smart contract as a unitary thing. Let me just stop the screen sharing. Most people think about a smart contract as a single thing, right? You have your assets, like the smart contract could be a DAO, or it could be a DEX, or it can be a lending pool. But anyway, it's just like one thing. You go and you transact into that, and now your assets are there. In order to create BitSNARK and to allow for smart contracts to be built on Bitcoin, which is what we're open sourcing today, we had to rethink this. We had to think about smart contracts from first principles, and we realized that actually smart contracts are modular. They have more than one component. They have the component which we can think of as the vault. Into the vault is where you put your BTC or your assets. That is the part of the smart contract that needs to live on the ledger. It needs to live on Bitcoin. It needs to live on Ethereum, because that is where the assets live. And the assets have to live on the ledger. But the second part is the instruction set, is the software that is associated with that. And because up until now both of these things have been unified and have lived together, that was all you needed. But what we've realized is that you can actually separate this. You can have an extremely light footprint vault, something which is so sort of unsophisticated in terms of the kind of computation it requires, that it can live on Bitcoin or really on any chain. So that is the vault. And then the software, if you take that off-chain, you can write an entire computer game. It can be massive, things that you would never be able to do with smart contracts today. But now we've got a new problem. We need to be able to communicate between these two things in a way which is trustless. And that is where the ZK proofs come in. So the ZK proofs allow us to reunify this so that even though only part of the smart contract is now on-chain, the vault, and part of the software is off-chain where it can be efficient, from the user's perspective, from a functionality perspective, it still feels like a unified thing because binding the two parts is the trustless communication of ZK proofs. ZK proofs that can trustlessly prove that the computation happened the way it was supposed to happen and be read by the vault. So what we've introduced with BitSNARK now is the ability to create these vaults on Bitcoin and then to write any complex piece of software that we want, compress that, translate that into a ZK proof, which can then be communicated to Bitcoin. And so we've had to not just use cryptography, but rethink from first principles what a smart contract is. And in doing that, we've completely opened up the potential space of what smart contracts can even be. Not just that they can be on Bitcoin, but they can be vastly more complicated, more sophisticated, more exciting than any smart contracts we've been able to imagine up until now. And where I think this ultimately ends up is eventually we'll be able to take any compute, any computation, anything that is happening on the internet as a whole, any internet-connected service, any digital service, and turn it into a smart contract, which is verifiable on a ledger, and specifically verifiable on the Bitcoin ledger. So, we've open sourced BitSNARK today. We've got really cool improvements that we're currently working on for BitSNARK and for other parts of Bitcoin OS, and we'll be releasing them as well. But even what we've introduced with BitSNARK is, it's the first example of being able to perform this kind of ZK verification. It's the first example of being able to do it on Bitcoin. It's the first example of being able to do it on Bitcoin with standard Bitcoin transactions. And it's the first example, living, breathing, that you can actually, as a developer, take a look at and play with today of this sort of new modular approach to smart contracts. So I'd like to encourage any developers who are out there, or any builders who are out there, to take a look at it. And I'd like to encourage any hackers, white hats, auditors to take a look at it as well. Let's, as a community, take this apart and figure out, is there anything wrong with it? Is there any way in which it could be improved? And perhaps most excitingly, what are some of the things that we can imagine doing with this that we haven't been able to